So guys, welcome to the fifth short video on Lanthanides. So let us apply whatever we studied in the last video into this topic. Now, I'll take two extreme elements of lanthanide series. One is La, hydroxide of lanthanum hydroxide, and lutetium hydroxide. Okay, so both are bases. What bases are these? These are Arrhenius bases because these are characterized by based on the ability to give OH minus groups in aqueous system. So now in aqueous system, do you think in aqueous system, do you think you have to think, okay? Just don't copy. Do you think ionic compounds will easily give OH minus, or covalent compounds will give OH minus? So which of these two compounds will give OH minus? Obviously, ionic character, better the base. Ionic character, easier the dissociation. Better the base. Right. Now, so let us now apply this thing with LaOH3 and LuOH3. So compared to La and Lu, which has a smaller size? Lu has a smaller size. Reason: lanthanide contraction. Lanthanide contraction is effective decrease of size from left to right in the lanthanum series. So smaller size, okay, smaller the size. Polarizing power. What polarizing power is what? Inversely proportional to size. So polarizing power will increase. Polarizing power will increase means what? More covalent character. More covalent character. So more the covalent character, less the ionic character. So less the ionic character, less the basic. So which means less the basic means what? LuOH3 will not ionize or dissociate easily. Ionize or dissociate easily. Okay. So which means what? If it will not ionize, will be present as precipitate. Okay. So however, if you take will be present as precipitate. Now if you take LaOH3 larger the size, lesser the polarizing power, everything whatever is happening here is opposite of that. Okay, so understand one side of the story, don't ratta maru. Understand one side of the story and apply here. Okay, so it's a very simple thing. So LaOH3 will dissociate as La3 plus 3OH minus. So these will be present in solution phase. Okay, so now let us apply this as a technique. So this much is clear, right? So let us apply this as a technique. So in precipitation method of separation, in precipitation method of separation, okay, what happens is we take a solution containing mixture of Ln NO3 thrice. So which is a general mixture of lanthanum nitrate. So when we add hydroxyl ions to this, what will happen is hydroxyl ions will go and replace the nitrate ions. So what you end up getting is LnOH3. So when you have a LnOH3, the weakest base among this, weakest base, that is LnOH, weakest base will precipitate it first, and strongest base is, for the sake of saying, I'm telling precipitated last, okay, which means it will be present as solution. Fine. So now if you take the series from left to right, the entire range of series, now what is it? Cerium, Priya and Pamela, okay, तब D O अरे तुम A B Duta. So whatever you have this thing, then what happens is this end of the series, the right end of the series is precipitate. Precipitate contains more elements of right end of the series. More elements of right end of series. Okay, so now what do? We filter the precipitate. 10th class concept. Precipitate is filtered off. Okay, now solution contains more of to the left of the series. Only partial separation. Here what happens? Only partial separation is affected, right? See why? Because see, they're all clustered. So now what do? See, take these atoms, take these ions again and redissolve it in, take the precipitate, redissolve in again, redissolve HNO3. Okay, and process is repeated to obtain greater purity. Okay, so that is how first separation technique, that is by separation by precipitation, is achieved. So thank you guys, see you all, bye bye.